Everyone, so welcome to this video. So in this video we're gonna discuss about function, but in this video we don't talk about a concept anymore. We talk about practice, how you can use function in real. Okay, so let's start the video. So I hope that you still remember this problem. So in this problem I give you a number n, so you try to find number n1 is the biggest right number smaller than n. So this is the code for find number n. So I hope that you feel comfortable with this code now. And we have another problem similar but different. We have a number n, so still we have number n. But in this problem we try to find number n2. This is smallest right number larger than n. So this is still the code of this problem. So I still hope that you can feel comfortable with this function. So no big deal. But there a big problem inside this guy. So we have something here. This line actually is so similar to the problem n1. So n2 and n1 they have a similar code. Not similar, they are exactly the same code. Some exactly the same some reasonable codes. So it means that if you can have a way, try to reuse the code of problem n1 for n2, you can save so much time. Yeah. So that is the reason why you need a function. So in here we zoom to the here we zoom to another concept we call that divide and conquer thinking. So this is that if you have an original problem and you try to divide the original problem into smaller problem. So in this case here we have an original problem, it can be n1 or n2, and you see that you can divide the problem into prime number n1 and n2, and n1 and n2 they have some share sub problem, that's the prime number. So if you can just write a function for prime number and apply to n1 and n2 problem, so it means that you just write a code for prime number just only one time and apply to second time. So it's better than the reverse method we already apply here to get solution. So let's jump into the problem. Okay, so we try to refactor this code. So let's write a code we call that right number handler. Yeah, that's it here. Right number handler.py here. So you can do some try concept. Say comment doctrine. So today 5. Okay, so we have a description. So this code implement a function to recognize a number e right or not. Okay, so what we need to do here. So we have a def. This is the keyword of the Python. So we have function e right here. Okay, and what we need to do here, try to provide input n. So for we don't need to talk about so much thing about here. So if n, so we can say it's number, so it's better than just n character number. So if number can divisible for any number inside the interval, so we can return it is false, otherwise we return true. Yeah, that's it. So we have function here, we got here. So in this function we try to in this problem we try to import a right number. So sorry, we have a right number handler. So see that we try to import right here. You see that we import this function. So we try to reuse this function here. So in here we don't need this code anymore. Just try to write down flat right is the number. You see that? And similar to this hint here, we don't need that anymore. So try to import the prime number handler module. Yeah, that's it. That's all we need to do. So here we try to answer plus equals prime number function and pass argument. So we need to check to check that is provide a good answer or not. So we say prime number n1 here. Try to input. Oh, sorry, I have some problem. We see that we have an error at line 9 of this module. Right number handler at line 9. So it's been that because we didn't define this number yet. So we fix error and enter 13. So we good now. We have a 11 is the right answer. And similar, try to test 13. We have 17. You see that? If you can divide your code into a module, something like that. So if you got error, if you get error, some pricing error, so you know exactly where you need to look at, because you divide your code into smaller part. So every time the error come into you just need to focus on smaller part. You see that? So it's more easier for debugging. So here, when you finish a problem right number n1, so if the right number n1 provide a correct answer for you and pass on test case on instant problem, on problem instant, so you can make sure that your right number function here is totally exactly correct. So if you move to the right number n2 and you got some error or not something not correct, so you can 100% believe that your right number module function here is totally correct. You don't need to spend time for debugging right number. Just focus on the rest of code in the right number n2. So it can save in a lot of time for you. So I hope that go through this example, you can understand how to apply function to your real application. Okay, so as I mentioned before, if you have any question, just feel free to send me an email. Okay, so see you later in next video. Bye.